This is the help video for the graph analysis, Keeling curve, and absorption temperature. So we have three different graphs. Let's check out what the directions say. The first graph is a graphical simulator. Since we're near the end of the year now, you should be really efficient or fluent in graphical analysis. So we're going to keep practicing. What it tells you to do is to open up this assignment, because obviously we've been doing this a lot. There's better in colored images and we can save paper by not having to print these things out. The first graph, figure A, you have to click this link and it will take us here. Now, if you look at the directions, it tells you to answer what's on the X and what's on the Y. Now, these graphs are getting more and more complicated. Instead of looking at two different graphs here, what they did was they plotted pretty much two different graphs on the same graph. So you'll find that we have two different Y-axes. If you look at the left, we see we have surface ocean, the pH that they measured. Over here we have atmospheric CO2. So whichever one of these you click, atmospheric carbon dioxide, you're going to be looking at this side to see the numbers for that. And if you click measured pH, you're going to look at this side to see the values, the numbers for that. So the directions tell us first, we answer those questions. Then at the bottom, click atmospheric carbon dioxide to show it. And you simply just click it. Boom. And then I ask you a bunch of questions. You can scroll over, and if you look up over here, it'll tell you the dates and the months of when that is. So we start at 1988. It ends at 2009. And essentially, you're just going to use your brain and analyze the graph and see what happens. Now, this question, when I say, why does it rise and fall each year? What I mean is, look, here in 1989, as you can see over here, keep your eye on this up here while I click over here. 1989, it says that in October 15th, we have low. And then that same year, 1989, now it's May, it's higher. Then the next year, on September, it's lower. May, higher. September, lower. May, higher. Why does it go up and down like this? We can certainly see a trend here, but that question is asking you, how come it goes up and down? It seems like it goes up and down each year. All right. And then I ask you to turn it off and turn on measured pH. Now we're looking over here for the pH. Remember, pH of 8.1 down to 8.06. I ask you what those pHs mean. I want to mention right here, if you look, the dates, here it's 1998, June 17th. Ooh, that's my birthday. Here it's 2003. So what you're seeing here is there's a gap in the data. They must have not measured the data here for 5 years. So it ends here and it picks up here. So this line is negligible. Don't worry about that. But you can see the data over here. So analyze that and answer these questions. The last thing I ask you to do is to leave on the pH and turn on the atmospheric CO2 so you can compare the both. What's happening to CO2, what's happened to the pH and the CO2 over the same periods of time? You're going to have to use your writing skills, your putting together some of your ideas to summarize what it's telling us. Here, that's that question. Now, B is talking about this graph right here. Again, we have a double graph. Two different pieces of data are plotted on the same graph. Over here, we see the CO2. Over here, we see seed temperature, and they have a key to show us which one is which. Do one at a time. What's happening over the months, 0 to 14? Well, there's not 14 months in a year, but I think they put 14 there just so that this wasn't on the line here. We have 12 months, starting with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What's happening with the seed temperature over that year? And what's happening with the dissolved CO2? That's how much CO2 is dissolved in the ocean at those months. Try to figure out a relationship between the temperature and how much CO2 can be dissolved. And you're going to summarize that here. Sorry, here. And then the last one, we have multiple graphs. If you look on the left and right, all of these graphs here on the left, here is the y-axis for them, dissolved carbon dioxide. That's how much carbon dioxide is dissolved in the ocean. And here we have what the pH is. So these are over the same amount of times, and these two graphs are for Bermuda. These are for Canary Islands, Carriacou Basin, and Hawaii. So Again, analyze these graphs and tell me what relationship you see. What correlation do you see between them? If you need help, just ask.